part, that is manage container images in Azure Container Registry, we need to know that why we need this container images. What are the benefits of what is the benefit of using container image is? So as we know that we are working with the systems, right? So I'm a developer, let's say, and I have a system with me. Now I got a requirement to develop a software that is written in a technology A, let's say Java. So for that, I need to have a system for that. So I will create a machine with that system, which is having the prerequisite for that same. After that, I got another project in the same duration. And in that, I have to work on a .NET project. So machine specifications are totally different. I got another project which needs a Linux operating system. So it's not possible for me as a developer to buy different machines because I might not have enough money. I might not have enough space. I don't have people to manage that. So in that case, we came up with the concept of virtualization. And we used to work with the virtual machines on our system. So we used to create a virtual machines, and in that virtual machine, we used to install the complete operating system that we need and install the softwares that we require. And we can run those machines in parallel. Even they can communicate with each other if we put them into a virtual private cloud, means virtual network. So they are sharing the same physical hardware of my machine. So we call the virtual machines as based on you know, physical hardware virtualization. So we say that physical hardware virtualization is a concept which is used with virtual machines because they are sharing the physical hardware resources. So if I have 1 terabyte of hard disk and 16 GB of RAM, so that 16 GB RAM and 1 terabyte hard disk is being shared between my main operating system plus the virtual machines that I have. Then we move to the cloud because on my system, I have a limited resources. So I can run limited number of virtual machines. So in the cloud, when we are working with the virtual machines, we are not managing the physical infrastructure. So the number of machines which we can create are much, much more, depending on the limits defined at a subscription level. But yes, they are based on the hardware level of virtualization. So if I am creating one machine for my software version 1, which needs 8 GB of RAM and maybe 500 GB of hard disk. So if new version of my application comes, I have to create another machine for the same. So just for a small minor change, I have to create new machine. So I have to pay for that machine 24 into 7. And it is heavy because complete operating system is running in that. So that's a big problem. And it is difficult to recreate that machine on development environment to the production environment or to the testing and staging environment because virtual machines are using VHD files or VHDX files, which has a size of almost 400 or 500 GB as configured by us. And we have to copy that over the network. That was a tricky part. As well as the machine contains the complete operating system, so it is heavy, it needs more resources, and it takes the same time to restart as my main laptop. So I thought about why not to find a way by which I can create machines or I can run my application in an environment which only contain the information which my application needs. And the operating system is shared by the base operating system or by some intermediator. And here comes the concept of container images and container instances. So containers, when we talk about containers, they are based on the operating system level of virtualization. So just want to share a bit of it. So here I have a machine with me. I'm talking about on my desktop, right? So I have a main machine. So this machine has some physical infrastructure as 16 GB RAM and maybe 1000 GB of hard disk. Now, I have my main operating system on it. This main operating system can take, let's say, 4 GB of RAM, and it took maybe 300 GB of hard disk. Then I would like to work with the virtualization. If I will go with the hardware level of virtualization, so I need to have a hypervisor on my system. If I'm working with the containers, so I need a containerized engine. Most popularly used engine is a Docker engine. So Docker engine. Now this Docker engine is going to provide the capability to run containers which will support Windows or Linux. On my system, I have this limitation that if I choose Windows, I can run only Windows containers. If I choose Linux, I can run only Linux. But in the cloud, it is not like that. Now, suppose I choose Linux, so I can create multiple containers on it. Container 1, container 2, and let's say container 3. Now, these containers will share the OS kernel. So all these containers will share the operating system level of kernel, OS kernel, which is provided by the Docker engine. So they don't need their own operating system. So each container will have OS binaries, application package that need to run, and a dependency. Any dependencies they have. Same here. It has its OS binaries, which they need, any application package, and dependencies. Same here. Now, the beauty of it is that they are not having their own operating system, so they are very lightweight. The resources which they need is quite less as compared to the virtual machines. So I can only, let's say I need 1 GB of RAM to run my application and maybe 80 GB of hard disk. Just giving an example, right? So that is the beauty of it. Now, they run in isolation with each other. They don't have any interaction with other containers running into it. If something goes wrong in one container, it will not affect the other container. As well as another beauty of it is that we can restart them. We can restart the container within few seconds. Usually, virtual machine takes minutes, but it takes seconds because we are not restarting the operating system. We are restarting the container, right? So it can restart it in few seconds. Now, another benefit is that it is easy to recreate. If I want to create the same container into different environment like production, testing, staging, so we can do it with ease. In case of virtual machines, we have to copy that heavy VHDX files or VHD files over the network. So that was a tricky part. But here it is quite simple because every container that you're working with is based on images. Images. We call it container images, right? Or container image. It contains a set of instructions that how the container need to be created, what OS binaries it needs, what application need to be installed, where it need to install, what dependencies it needs, and when it starts, what will be the starting point. So everything is defined in the image. So I can have as many images as I want. Now, these images are stored in two different locations, private repositories or public. Private is for organization. If I keep any image here, so it is only applicable or it is only visible to the employees of the company who has permission to work with it. Public, basically, as you know, it is a public repository which is available to everyone, right? Like a Play Store. This is a public Play Store. This is a private Play Store. Now, in here, we call it container registry. Private repositories are called container registry, Azure Container Registry, and public one is called Docker Hub, right? Docker Hub. Now you need to understand how to work with that, right? How the things work. Then I'll jump back to the topic, right? So if you want to work with any of these capabilities, so you need to follow some steps. The first step is you have to create an application. You have to create an application that need to be deployed as container. It is a normal application. It can be a website, it can be mobile backend code, it can be any API, whatever it is. Now you create an application. Step is step one. Now, step two, we have to create a Docker file. We have to create a Docker file. So a Docker file is a file which has the name Docker without any extension, and it sits in the root folder of the application, right? So create a Docker file in the root folder of application. It contains the instructions which defines that what container we're going to have. But unfortunately, we cannot use this Docker file directly. So step three, we have to convert this Docker file into Docker image or container image. Container image. Now, this container image basically is the one which we will be using it to create containers. Now, when I create this, convert this Docker file into container image using the Docker command or the ACR commands, right? Azure Container Registry commands, then I want it to be used by my colleagues or people all over the globe. So I have to push this image into either container registry or Docker Hub. Container registry is private and Docker Hub is public. Now, anyone who has access to it or who wants to use this, right, they can pull the image from repository to create container. To create container. So I'll say that I would like to create a container from the image which is stored in my container registry or in my Docker Hub. As soon as I specify that, so my container will be created with the information that is defined in that container image. And that container is basically running its own environment. And it is lightweight, though it is running 24/7, because if it is stopped, I cannot access the application that is running inside. Right. But if it is running 24/7, I can submit my request that will go to the application that is running in that Docker file that is specified by the Docker file, and then I can access it. But the beauty is that I'm not holding, this container is not holding the complete operating system. So that's why it is very lightweight. And no matter in which part of the world I am, I can connect to the container registry or the Docker Hub, get the same image, and create as many containers as I want. So this is the idea behind it. Now, how to do all these things? We will be talking about that. So introduction. In this module, we will explain the features and benefits of Azure Container Registry, describe how to use the Azure Container Registry tasks, explain the elements in the Docker file, and build and run the image in the ACR by using CLI. Okay, so we need to understand the container registry first. Then I will be explaining the Docker file, how to convert it into image, put that into container registry. We'll see step by step. So container registry, it is basically a centralized place where I can keep my container images, which can be used by the developers to create containers, right, for their applications. So as per the definition, we can use the container registry service with your existing container development and deployment pipeline, or use Azure Container Registry tasks to build container images in Azure. So if I need to deploy my application once, or I want to configure the CI/CD pipeline, then those resources can communicate with my container registry to find the right image and then create or deploy the container based on that. So there are many use cases where you can use it. So as I was talking about, once your image is there in the container registry, you can pull images from the Azure Container Registry to various deployment targets, like scalable orchestration system. I'm talking about DevOps. The managed containerized application across the cluster of hosts, including Kubernetes, DC/OS, Docker Swarm. So different containerization engines are there, which we can use to manage the containers based on the container image stored in the container registry. So if I have to create one container image, I can do it manually. But if I have 100 containers need to be managed at the same time based on the same image, and based on the flow of the customer request, I want to create or delete the container instances, so it's not possible for me to do it manually. So I need a orchestration platform like Kubernetes, right, Docker Swarm to perform that. So yes, container registry can be integrated with that. We have Azure services. There are so many Azure services that has the ability to create its instance based on the images running in the or stored in the container registry. Azure functions is one example. When I create an Azure function, it needs a logic, it needs some code, and I need that code. Either I can start creating the function from the scratch and type every single piece of code, or I can create a container image. And based on that, I can create my Azure function. Or web app. If I'm creating a web app, like what we discussed in the module 1, if we create a web app, so that web app needs an application. So that application might be coming from the container registry in the form of image. So I can do that. In that case, my web app is not running in the virtual machines. It is running in its containerized application. Now, whenever we are planning to create a container registry, we have to understand that what plans are associated with that or what service tiers are available with that. These tiers provide predictable pricing and several options for aligning to the capacity usage patterns of the private Docker container registry in Azure. So it is a private registry. So whenever we are creating a Azure Container Registry instance, we can choose a basic tier, standard tier, or premium tier. Now, all of them will provide the same capabilities. The only difference that you will get, standard tier and premium tier will have more space, more images can be stored into it. As well as premium will give you extra capability of geo replication for managing a single registry across multiple regions. So that if one region fails, you can access it from another region. You can also put it in a network as well. So that is the difference between the basic standard and the premium. Otherwise, the capabilities are the same. Now, as I was talking about the storage capabilities, right? So basic, standard, and premium container registry tiers benefit from advanced Azure storage features like encryption at rest for images data, so that we can provide security, geo redundancy for the image data protection that is available in your premium plan. So as I was talking about encryption at rest, so as soon as I create any image and I put that into container registry, it will be by default stored in an encrypted format so that untrusted users can't access it. Geo redundant storage. To understand that, we need to understand the regional storage. Azure Container Registry, when you create that instance, it is associated with certain region, right? So all the images that you stored in that registry will go in that specific region only. And I choose the region based on where my customers are, right? I want to consider the cost, latency, and compliance requirement. And then I can choose a specific region. By default, all regions except the Brazil South and Southeast Asia has the ability to store the images into the paired regions, which are in the same geography, except the Brazil South and Southeast, because these regions doesn't have the paired region in the same geography. Now, why we are replicating them? So that if one region fails, I still have a backup in another region so that I can work with it. If I don't replicate it, I won't be able to recover my images. So that is the beauty of the geo-redundant storage and geo-replication. It provides high availability, right, when I'm working with that. And geo-replication is only available in premium registries. Means when we create a Azure Container Registry with the premium tier, then only I can go with the geo-replication. Now, build and manage containers with tasks. Now, whenever I would like to play with tasks, so task is some extra features which help us in performing some specific operations. So ACR task, as you can see, is a suite of features within Azure Container Registry. It provides cloud-based container image building for platforms including Linux, Windows, and ARM templates, and can automate OS and framework patching for your Docker containers. Now let's take some scenarios to understand this in more depth. So when we talk about ACR, so ACR task supports several scenarios so that you can build and maintain your container images and other artifacts. So first is quick task. Like for that, I can explain it in a way like, let's say you are building and pushing a single container image to a container registry on demand in Azure without needing a local Docker engine installation, right? Like we are using a command docker build, docker push to work with it. So Azure Container Registry has an inbuilt task that will allow you to perform that operation for you when I'm pushing that image. Or automatically trigger task, like enable one or more triggers to build an image. Like whenever my source code is updated, I want to create a task which will run automatically and it will going to build and push that image into the container registry. So Docker build will going to convert your Docker file into your image, and Docker push will push that image into the container registry. Or maybe you want to trigger on the base image update. So when you create a Docker file, that Docker file will say that which image it is based on. And whenever the base image changes, so you want to trigger an action so that it will update all the, you know, images which are based on that. So we have multiple options to configure it. Similarly, multitask or multi-step task. Extend the single image build and push capabilities of ACR tasks with multi-step, multi-containers based workflow. Like I want to create an image of my application, then I want to run in a production, as well as I want to create image for testing environment, and then I want to create an instance of it, container of it, which will run in a testing environment. So I want to perform multiple tasks, and that can be done with the tasks option. So it's time for us to continue with the first thing that will help you in understanding what is the Docker file look like. So as per my instruction, once you create an application, you have to create a Docker file in the root folder of an application, which will tell that when container is created, what that container will going to have and where. So that is the very important file that we have to play with. Now let's see how to work with it. So we're going to explore the elements of a Docker file. So Docker file is a script that contains a series of instructions that are used to build Docker images. And Docker file typically include the following information, as you can see here, like it contains the base image, it contains some operating system packages, updates, installation, softwares, and so on. Now I'm going to explain this part one by one. So as you can see onto the screen, right, we have step one, specify the parent image for the new image. Basically, every Docker file is based on the layered architecture. Layered architecture means one image is based on another image so that you don't have to redefine everything again. So I already have the image. Let's say here I'm working with the image of Ubuntu, right? Which will install the Ubuntu operating system. Or it might be possible I'm creating an application which needs a .NET runtime. So first command can be used to use that image. Here I'm using Ubuntu, but I can also use the .NET runtime 6.0 image, which will bring it into my scope. Then we can also work with other commands. Just give me a minute. So here I am running a command, run apt. So means I'm running some updates. I'm installing some packages which I need to have in my container. So whenever this container Docker file is converted into image, and when I use that image to create a container, it will going to run these commands into the container to deploy or to install some packages. Right. I can start Nginx server where my application will run. Right. I can copy some environment settings into the container folder which is called etc/nginx, and so from my current folder has a default folder from where I want to copy that. Now the most important part is a working directory. So in my Docker file, I can say working directory is /app. Means when container is created, in which there will be a folder called /app or app folder, which I want to set as my current directory. Now, next command is saying copy website code to the container. So according to it, it says that whatever I have on my project in the website folder, I want to copy all the files into my current working directory, that is /app. Then I want to expose that application over the port 80. So when any request comes to the container with at port 80, it will be mapped to the port 8080 of my application. And then I'll specify the entry point. This is a command. This command will tell the container that when you start, which application to expose to the outside world. So this is the Docker file. And you